Hello everybody, welcome to a new video from MCU Park. In today's video, we will make a filtered fume extractor for the soldering fumes. Most of the people creating similar extractor are using a PC fan, which is usually so small and doesn't have the capability to draw enough air through a proper filter, unless you use several fans stacked together. So I decided to use this radiator cooling fan, which has a 7 inches blade diameter that can do 800 CFM. A CFM is the cubic feet per minute, which is around 22.5 cubic meter per minute. This should be creating a very good suction ability, especially with the type of filtration that we are going to use. The fan uses 12 volts and consumes 80 watts, which is a bit less than 7 amps. To control the fan speed, we can use any motor speed controller from the market, but I already have this LED dimmer that works between 12 and 24 volts. It supports up to 30 amps, so a maximum power of 720 watts, which is a way overkill. But I'm using it because I can remotely control it using an RF remote control, and I was already having it. The only issue we have is that it is not designed for controlling motors, which means it is not protected against motor-induced current produced by the motor when we are trying to stop it or reducing its speed. We will cover this flaw by using a Schottky diode 1N5822 connected to the output of the controller to protect against the reversed current. I will use this HP 12V 750 watts power supply that was salvaged from old servers. I got several of them while working on a previous video for creating a high power supply. I paid around $9 for it. I also have a faulty power supply backplane, which I got during the make of that project. It went bad and I had to replace it. You can find a link in the description for that video. So, I salvaged the power supply recipient socket from that old board to solder the cable to it instead of soldering directly to the power supply board. I will be using this switch for turning the power supply on and off by connecting it to pins 33 and 36. Using those high power components will give me the ability to replace the fan with a higher power and more airflow if this one didn't work sufficiently. The extractor box turned out to be large enough to take days on my 3D printer. But luckily, I have access to a laser cutting machine, so I used it to cut 1/4 inch plywood for making the box. You can use whatever easier for you. Just make sure that the filter compartment is airtight to ultimately prevent air leakage. I also made this fan mounting plate that will be mounted using machine screws to give me access to the filter, either for cleaning or to replace it. The intake hose will be attached to this 4-inch hose recipient flange, which will be fixed to the extractor body using machine screws too. This is how we should assemble the extractor case. And here is where the power supply and speed controller will be living. The space between the fan and the air intake will be filled with the filtering materials. I'm using a fish tank filter foam for easy cleaning, and behind it I will place an active carbon filter. Now it is time for gluing the box. I'm using a special type of tight bond wood glue that is usually used for trimming and molding. It is so strong in gluing wood with the small areas of contact and will also enhance the airtightness of the filter compartment. While the glue is drying, let's see if the LED dimmer will work as motor speed controller with the fan motor. If I'm wrong, the dimmer will release its magic smoke, but I feel confident that my simple solution will work. I will use the power supply created in the previously mentioned project that can provide over 200 amps. Let's give the fan all the power it takes. And this is a moment. Hold on. How many of you would expect this to work? Please let me know in the comments below. Let's see. Phew, it's working. Just kidding. I knew it will. The speed control is functioning perfectly as well. Now, it's the power supply turn. I removed all unnecessary pins from the socket to widen the space and eliminate any confusion. The most left pin is pin 33. Pin 36 is the one just after it. We will use those for turning on and off the power supply. The most right group of pins are connected to the positive pole of the power supply, and the negative is connected to the middle group of pins. The motor will be using a maximum of 7 amps. I will use 2 pins to connect the wires providing power to the speed controller. I 3D printed this back cover for the power supply socket to protect the pins and prevent any possible unwanted connections. It works great and looks nice too. After soldering all the required terminals, let's see if the on-off is working. If you look at the LED at the front of the power supply, you can see it turning on and off. Now, it is time to measure the output power. Great, we have a solid 12 volts output. Let's connect the speed controller and make it ready for the final assembly. The glue has already dried, and I painted the box in a bright yellow color. I think it is a good match for all the other pieces that I'm using. Let me know in the comments if you prefer a different color. Let's see if it works. It is working. But what about the suction power, especially with the filter in place? Not bad, looks promising. Let's connect the hose and the intake hood. Now, it is time for real-life test. Before turning it on, let's see how does it look. Oh, it looks nasty. Let's turn it on and see if it has any effect. Wow, that's impressive. It absorbed all the fumes and smoke coming out of the soldering iron. Trying the different speed levels, it kept working efficiently till 75%, but at 50 it was so weak, and at 25% it was almost useless. Okay friends, that were all I have for you today. If you have any suggestions or questions, please comment below. Appreciate your time, and I hope that was helpful. Thanks for watching, and see you in my next video. Thank you.